time. In December it looked like this. In January it looked like this. Why is it changing all the time? As Dr. Pettit showed you, we're getting these very long period events on the helicorders. That's gas coming up, and as it comes up, it's changing the configuration of the bottom. These are all the depth profiles, and you can see every time it's surveyed, it's changing. And the reason is we've still got a lot of fluid coming up, gas coming up, and it's just changing the bottom each time it comes up. So the sinkhole is changing all the time. The other thing is, in the January 19th event, we saw some settlement of the Oxy 3 pad. We've got two water level sensors out there. One is in a well to the north side of the sinkhole. This was on Oxy 3 pad. And you can see after they calibrated the instruments, the two showed essentially the same water level changes up until about the 15th. They started to divert. They started to no longer agree. Well, the reason this was because the Oxy 3 pad during the January 19th event actually settled at least 6 inches. So during all that seismic activity and everything else, the pad itself settled about 6 inches. In addition to that, in the sinkhole water levels, we can monitor the burps, so we see them on the helicorders, we see the long period events, but we're also seeing them on the surface, and we can actually calculate the volume of the void space that was filled during a given burp event. This burp event here, it went way up and then down and then back up. This was about 15,000 cubic feet of water was moved down the to the bottom of the sinkhole, went out the bottom of the sinkhole. This much bigger one, which occurred, this was the big one that Dr. Pettit showed you at 10 a.m. in the morning. 6 o'clock at night, we had another one that I don't think anybody observed that moved about 40,000 cubic feet of water. So now we've got the instruments, both seismic and water level recorders, so we can see how this is all fitting together and what's going on. Last thing I'm going to talk about here is the cavern stability. That's part of what we've got to look at. We started off back in September, everybody was mainly worried about the Oxy 3 cavern. Because of a lot of things going on, we've expanded the scope. We're now looking at all the caverns shown here. We're looking at Oxy 3, obviously, Oxy 1, 2, 9, 10, Crosstex 2, and Crosstex 1. They're all included in the analysis. We determined probably a month and a half ago that you can't just look at one, you've got to look at all of them. So that's what we're doing. The Itasca modeling is going to include all of them, so not just one. What I'm showing here are two cross sections so you can see how the caverns relate to each other. This is a west to east, Oxy 3 caverns here. This big long one here is actually Oxy 2. That's the one that's still being brined. They're just brining the top of it. They're not brining the bottom of it anymore. This is Oxy 1, and this is Crosstex 2. Looking south to north, this is Oxy 10, 9, 2, and Oxy 1. And I'm just showing you this because we're going to be talking about this over the next several months. You need to understand how these caverns relate to each other and what we're studying and evaluating. The sinkhole burps, as we've talked, tell us there are void spaces down there. We've got an idea how big they are. I just gave you some numbers. The January 19th event was a good thing from understanding what's going on. We know we moved a lot of gas and water and liquid, but what we did not see, we didn't see a big bubble of gas come to the surface. And we think the reason is the sand and gravel in the alluvial aquifer, the gas coming up is breaking up that bubble. into a whole bunch of little bubbles, which is what we need for safety of people driving up and down 70 and everything else. Go ahead. In December, I showed you this graph. We showed declining pressure in cavern 3. We didn't know what was going on. We still really don't know what was happening here, but I showed you this. Pressure was declining. In true Bayou Corn fashion, it came back. And now we've got some pressure kicks going on in here, where here we went from about 600 psi to 1150 psi in the cavern. They bled off crude, and it went down here, and it built back up very quickly, and then they bled off the rest of the crude out of the cavern to where they were just producing brine. So now we're seeing the pattern we actually saw before December. The 119 burp event was this little blip here, and you can see some other blips going on in the pressure in the cavern. We're not exactly sure what's causing those, but they do seem to correlate with some of these micro earthquakes that Dr. Pettit talked about. So the cavern pressures are actually reflecting some of the rock movement going on wherever it's going on. Back up. This spike here was due to when they went in to tag the bottom, and we're not exactly sure why the pressure went up 400 pounds, but that's what this spike was. It was not related to a micro-earthquake or anything, but we're seeing a lot of pressure changes here. That's because the cavern has now reestablished communication with the collapsed rock column outside that's communicating with sinkholes. So we went through a period of about 6 weeks where the cavern pressures were not reflecting what we saw going on in the sinkhole. Now that communication's been reestablished. Next, the good thing in this is Oxy 2, which is about 300 feet east. This is the 119 burp event, and what they were doing is replacing the diesel blanket on the cavern, in the cavern here. That's what this pressure increase was. But you can see throughout that entire event, Oxy 2 pressure was very steady. And that's exactly what you want to have a stable cavern. If we'd seen pressure spikes here due to all the activity going on that you've seen, the earthquakes, micro-earthquakes, it would have been a different story. This is good news, that the Oxy 2 cavern did not feel what was going on over in the Oxy 3 area. So from a cavern stability standpoint, this is about the best news we've had in a long time. These little blips here, they were just finishing pumping the diesel. We've got the operation records. So you can see, you're not seeing the ups and downs or anything. It's very stable. And by the way, on that, we get 10-second pressure readings. So all the caverns now, we get 10-second pressures. Here's the bottom plot that we talked about. It filled up a lot, then it flattened out. From 117, when they tagged it here, 131, cavern filled 100 feet in 2 weeks. That's the biggest fill we've seen since the cavern was entered back in September. This is when all those micro-earthquakes and everything else were going on. So whatever was going on, it put 100 feet of fill. And don't forget, this cavern is 300 feet across. It put a lot of material at the bottom of that cavern. We've got about 400, the top of the cavern is 3,400 feet. We've got around 460 feet to go before it's full, and as we talked about, that's when it actually becomes more stable. So we filled up in 2 weeks 100 feet of cavern, which means we moved a lot of material. The Oxy 3 summary, the cavern is now in communication with the disturbed rock column. It's not making hardly any gas anymore, but it is making liquid hydrocarbons. Not a lot, but a little bit. The Oxy 3 pad was damaged in the seismic event we talked about. You probably heard the cracks were observed on the pad and everything else. That during all the activity, when we were on the phone trying to coordinate things, Mike Taylor was out there getting all the heavy equipment and everything else off that pad. And the pad right now, work is not allowed. Path forward, here's where we're at. We're working on reducing the methane in the aquifer. We now know how to do that. We're evaluating the stability of the rock zone and void spaces. We've talked a lot about that tonight. I'm not going to reiterate everything we've talked about. And we're evaluating the stability of the western side of the dome. Those are the three main focus of what we're working on right now, and we'll continue to work on until we come to resolution of this thing. Questions?